Hey guys, this is your notes for section 4.5, example 1. What we're going to do now is we are going to have to come up with our equation of a line of best fit, but now we are going to let the computer do it for us. So this is pretty nice. If you can just follow what we do with our on Desmos, it's actually going to feed back to us what our slope and our y-intercept should be to represent the line of best fit for these points. Okay. So the first thing you want to do is copy all these points down. And if you need to pause, that way you can flip back and forth. But get all these points down. And then notice what we're comparing. We're looking at the number of weeks that have passed and the cumulative snowfall. Cumulative is added up. So in 1 week, we have 11 inches. In 2, we have 18. So you can see we just keep adding, getting higher and higher because we expect that. Every week, we expect a little more snow. Our first thing we have to do is, using functional notation, write an equation for the line of best fit. So now we are just going to go to our Desmos calculator. There we go. Sorry about that. I don't know why my window wasn't where I wanted it to be. And I actually already had these in here, but I'm going to get rid of them so that way we can just start from scratch. So in order to come up with your line of best fit, hit the little plus symbol up here. It's to add an item. We need to add a table. That's what the information we were looking at, right? So now we're just going to put in the first week, 11 inches. The second week, 18. Third week, 32. Fourth week had 52. The fifth week had 72. Sixth week had 82. And now we have all of our points. If you can't see all your points, you may need to move your graph around or zoom out or zoom in. Okay. So now we have all of our points in a line. Now we're going to let the computer generate the information for the line of best fit. So what you're going to do is you're going to use your general form y equals mx plus b, but you have to put it in this way. Y sub 1 and then a tilde, which is the probably up by your 1 on your keyboard. It's right above the apostrophe, I believe. So look by 1 by your keyboard, and it's a little tilde. So y sub 1 tilde m x sub 1 plus b. You see a line of best fit appears, and it gives us all the information we need. You can ignore r squared, and you can ignore the residual part. Just look at our r value, our slope, and our y-intercept. For us, what we care about right now, they asked us for our line of best fit. So we need to use our slope and our y-intercept. You can round it to the nearest tenth. So your slope will end up being 15.3. Okay. Your y-intercept, negative 9.2, is what we want. So now let's go back to here. Excuse me. Let's go back to our notes. And I apologize. I have too many things open right now. Let's go back to our notes, and we can put in f of x equals 15.3x minus 9.2. Okay. So now we want to use our line of best fit to predict the cumulative snowfall in week 5. See how we don't have any information up here for week 5? What we can do is use our line. So now let's go back to our line, and we can zoom in a little bit if we want, or we can just follow it. We want where x is 5. So we can do a couple different things. You can just follow your graph, 2, 3, 4, find where x is 5. Right here, 5 comma 67.5. So in the 5th week, we would assume we would get right around 67.5 inches of snow cumulative. Another way to do this, if you just want to be quicker, you can actually put in your equation and just plug right into your line. So remember how we had 15.5x minus 9.2? It'd be 15.5, but instead of x, we're talking about the 5th week minus 9.2. And that gets us really close to where we were at. And since this is going to have some rounding errors, that's acceptable. Okay. Oh, excuse me. That should have been 15.3. And that gets us right to where we wanted to be. Okay. So remember, for this part, you're just plugging in for X. They asked us what the snowfall was compared to the number of weeks. So that's where you just have to plug in your X. Okay. Now let's go back to our notes. So we would expect to have 67.3 inches of snow accumulated or cumulative. Now use your line of best fit to predict the cumulative snowfall during week 25. So now when we go back to our graph, notice the points stop right here at 6. But what we're going to do is we're going to make a prediction. We're going to go way out here, and we can say, okay, our line of best fit, geez, way out here. We got to follow this really far. 25 is right there. Let's see if we can get it exact. I had it. There we go. 374.4. So 374.4. Or you could have gone to this line and just plugged in 25. See how sometimes it's easier to not use the graph? If you understand how to use the algebra, we're just plugging in a new x and we're seeing what comes out. 373.3. Now they're going to be a little bit different because remember, we rounded here for our slope, okay? So they're going to be a little bit different, but I would never mark you off for that because to be honest, who's going to notice the difference between 0.03 inches of snow? Nobody. So that rounding error is okay in this class. The biggest thing is you understand where it comes from. We had to create a line to represent that table. The line that we came up with was f of x equals 15.3x minus 9.2. Now we're going to use that line to figure out how much snow or predict how much snow we can have in week 5. And then we wanted to see how much we could have in week 25. And we end up in week 25, 373.3 inches of snow. And for some reason, it's not letting me put my answer in here. But I'll just do it over here. So it'll be 373.3 inches. And if you were off by 3 or 4 inches, that's fine. It's not going to be way off, okay? Now, what is the correlation coefficient and what does it suggest? So now we're going to go back and look at our correlation coefficient. That was R equals 0.9904. That is going to be plugged in right here. So you can just put in R equals 0.9904. Let me double check that. Yep. So what our correlation coefficient means. Remember, our correlation coefficient is just a number that represents how accurate our line is. Go back to that table, or if you don't remember, go back to the YouTube clip just before this one where I explain correlation coefficients. What this one means that our line of best fit is very accurate, okay? Or our line of best fit has a very strong positive correlation. In other words, our line is going up. We're getting more snow as the weeks go on. And Our line of best fit is very close to the data. So I would believe anything that our line tells us very strongly. Okay. I suggest you might need to go back and watch this video once or twice because there's a lot of information I gave. But the gist of this video is when you are given a table, you can take that table and plug it in on Desmos. Desmos, if you put in the y1 tilde mx1 plus b, will then spit out values that give you the equation of the line of best fit. This equation of line of best fit can now be used to make predictions. That's the whole point. We have this line that we can now make predictions.